All right, let's do this. I saw some people looking through their packet making comments already. This unit still has proofs in it. All right, it's actually a new kind of proof I'm going to show you, but that's later on in the unit. It's not proof heavy at all. But what it is heavy in is new vocabulary. All right, new vocabulary, very heavy in. Right. We are going to be dealing solely in a triangle. New parts of a triangle we may or may have not have heard before. All right, and new facts about the triangle that you probably haven't heard before. Also, a quick note, there's no assignment sheet. I'm not going to pass out an assignment sheet for one day. All right, so the homework is at the end of the notes today. Okay, down at the bottom of the packet. All right, I wasn't going to hand out an assignment sheet for just one day. All right, let's get those straight edges ready to go, because the first new vocabulary term I'm going to show you is concurrent lines. Concurrent lines. Those are three lines that intersect at one point or more. You can do 4, 5, 6 lines, but at least 3 lines that intersect at one point. So in that first box I've given you over to the right-hand side on top, could you draw me 3 concurrent lines? 3 lines that all intersect at a point. And I do not want to call those 3 lines that intersect at a point. Let's start using the vocabulary concurrent lines. Those are concurrent lines. Okay, concurrent lines. That point that they all intersect at, we are also going to give a name. Let's not call it that point anymore. We're going to call it the point of concurrency. Yes, point of concurrency. That's the intersection of the concurrent lines. So there's my point of concurrency. All right, so we got concurrent lines and where they intersect called the point of concurrency. That's going to come into play here twice before we leave today, twice. All right, quickly, circumscribed, number 3, circumscribed. A circle containing a triangle whose vertices are on the circle. We say that circle is circumscribed. Let that roll off the tongue so we don't have an incorrect pronunciation of it. All right, circumscribed, everybody, circumscribed. All right. So we have a triangle, so draw yourself a triangle. And then we have a circle drawn around it, but we have to make sure what? Each of the 3 vertices of the triangle are on the circle. Can you do that? Quick sketch. All right, quick sketch. Yes, sir.
I'm just going to try replacing its batteries first, and then we'll...
Okay, I did that today already.
Oh, already?
Yeah, I did that today.
Okay.
That's fresh batteries in there,
Okay,
and they're still not turning on and off.
Well, I'll... Just make sure these are right. Okay.
Okay, so everybody has it touching the vertices. Look good? Circumscribed. On the outside. So you may want to make a note right now. I see circumscribed. I'm thinking the outside of the triangle. All right, outside. That circle's on the outside. What if I wanted to put the circle inside? I call it inscribed circle, an inscribed circle. And the circle touches each side of the triangle in exactly 1 point. Okay, so again, I'm going to make a triangle, but now I'm going to put the circle inside. So each side touches it. Each side of the triangle touches the circle in 1 spot. Can we get that done? Sure. Let's see. Oh.
Actually, let me make sure that has fresh batteries because I don't know.
Okay.
If we had just
The old one I gave you had fresh ones if you don't want to use another one. There we go. Circumscribed around outside the circle, inscribed inside the circle. All good. All right, are you ready to meet your first set of concurrent lines and your first point of concurrency? On a graph, here we go. We're going to have a triangle on a graph. I'm not just going to give this to you. You guys are going to figure this out in your groups. So go ahead and graph triangle ABC. There we go.
Okay.
Looks good. Thank you, sir. Appreciate it. Okay, here we go. Each group's going to have an assignment. First one, I need you to find the midpoint of AC for me. Find the midpoint of AC, and we're going to call that point D, everybody. This group right here, this group right here is going to find point D. So is this group right here, just so we can confirm, all right? Point D, midpoint of AC. Group 2, we're going to call this point E, which will be the midpoint of BC. All right, I'm going to go this group right over here next to the door is group 2, and this group right over here is group 2 as well. Find the midpoint of BC. And then finally, I'm going to have the midpoint of AB, which we're going to call point F. That crew right over there, and that crew in the back. All right, you guys are going to be on my slopes here in a second in the back. All right, so those two groups right there, find me the midpoint of AB and call it F. Go ahead. Midpoint formula, I'm not going to give it to you. By the way, midpoint formula, it's got a plus in there. All right, some of you may want to look that back up again, considering what I saw in the test. All right, it's got a plus, not a minus. Let's go. Find the midpoint, confer with your group, and then let's get back here. Okay, let's go around here, making sure both groups got the same thing. If both groups didn't, let me know, please. Midpoint of AC, what groups, what do we have here? 4-1? We all good in agreement? Yep, 4-1. Everybody copy it down. Point D, 4-1. And go graph it right now while we're here. Go graph it. 1, 2, 3, 4, 1. Yeah, that looks like right in the middle. Perfect. And we're going to call that point D. Okay, midpoint of BC groups. What do you have for me? I got 8-2. Confirmed, 8-2. Okay, 8-2, everybody. Point E, 8-2. Go ahead and graph it. Perfect, right in the middle. Call that point E. And then how about the midpoint of AB groups? 5-4. 5-4, good? All right, yep, 5-4, point F. Go ahead and graph it, everybody, 5-4. Perfect. All right, we're progressing here because there's something you're going to do with those midpoints in a second. Now let's go to the next part. All right, same graph, same triangles. Now we're going to turn our attention to slope. Okay, so I'm going to have one group find the slope of, actually two groups, so we can make sure we confirm it. Slope AC, and then find the slope that's perpendicular to it. What should be the relationship between these two when you're done? They should be negative reciprocals of each other, yes. And if you don't want to use change in y over change in x, you can use rise over run, since you just graphed it, all right, to make things go quicker, but that's up to you and your group. All right, slope of AC, two groups that haven't gone yet. Slope of AC and the perpendicular slope, both groups in the back. Slope of BC, let's have these two groups right up here. Slope of BC and the perpendicular slope. And then you guys up front here do the slope of AB for me. All right, you guys get to relax, but you're going to help me graph it, though. Please do the slope and the perpendicular slope. Finish up. Make sure you confirm with your group before we move on. All right, here we go. Let's get going. Groups in the back. What'd you guys find for the slope of AC? Negative 2 over 3. Everyone's good back there. All right, let's copy it down, and that's correct. Negative 2 over 3. So what would be the slope perpendicular to AC? Positive 3 over 2. Good. Everybody good so far? All right, now we're going to go right to the graph, because here's what I want to do. I want to start at the midpoint of AC. So everyone go back right now. Start at the midpoint of AC, which we called what point? We called it point D. So everybody go to point D, and using the perpendicular slope, 3 over 2, I want to make 2 more points. Up 3 over 2, up 3 over 2. All right, so go to point D right now. I'll do this in yellow for this one. Ready? Up 3, 1, 2, 3 over 2. One more time. Up 1, 2, 3 over 2. Grab your straight edge. Draw that line in. Yes, Emma. Did I go over too many? Probably. So I go up 1, 2, 3 over 2. There we go. Better? 1, 2, 3 over 2. Well, thank you. Okay, grab your straight edge. This is done with the straight edge because I want this line to go through. Somebody give me a vocabulary term for this line we just drew in. Where does it go through? The midpoint of AC, and it's what to AC? Perpendicular. Give me a name for this line we just drew in, Caitlin. This is a perpendicular bisector for AC. Everyone correct? Everyone agree? Okay, I want to do the same thing now for the other segments. All right, so let's go back to our chart. Who had the slope of BC for me? Slope of BC. What group said BC? Slopes of BC? What do you guys have? 3, yes. Slope of 3. So what's the slope perpendicular to it? Negative 1/3. Okay, everybody go back. What did we call the midpoint of BC? E. So everybody start at E. And now I'm going to look from the two groups I didn't call on here for the slope. Ready? How do I make 2 more points using the slope negative 1/3? Where do I go for point E to make it a slope of negative 1/3? Where should I go here to make 2 more points? Okay, down 1. Don't tell me over 3 because I could go a couple places. Down 1. 1, 2, 3. Or you could have went where? Up 1 over. 1, 2, 3. Yep. So go ahead with a straight edge, not your free hand. It's important that you use a straight edge here. Come on. All right, one more to go to prove our point here. One more to go. You guys don't, some of you I think know what's happening here, but we need one more here. Who has the AB one? Slope of AB groups. What do you got for me, ladies, gentlemen? 1/4. Confirm, 1/4. Here we go. Copy it down. That's a slope of 1/4. So what would be the slope of a line perpendicular to it? -4. Here we go. So everybody go back to side AB. What was the midpoint of side AB? Point F. Yep. All right, groups that didn't help me out with the slope. Now I got a slope of -4. Where do you suggest I go to get 2 more points? Starting at point F and a slope of -4. How do I get 2 more points? Okay, I can go down 1, 2, 3, 4, and over. Right 1, yep. And I could do that again, or I could go up 1, 2, 3, 4, and to the left 1, yep. Again, with the straight edge. And somebody let me know, hopefully, if you've been using a straight edge, what's going to end up happening here. Hopefully all 3 lines intersect at the same point. We get a yes on that? Okay. What do we call those lines? Concurrent lines. And no, ready? And what did we call those lines specifically? They're the what of each side? Perpendicular. So what did we just find out here? Let's sum all this up. That all 3 perpendicular bisectors are concurrent. In a triangle, if I drew in all 3 perpendicular bisectors every time, they're always concurrent. And what's that point of intersection called? Point concurrency. For now. We got a new vocabulary term for it. I don't want to call it the point of concurrency. If it's the point of concurrency for 3 perpendicular bisectors, we're going to give it a specific name now. Okay? This is only for the perpendicular bisectors, though. All right? That point of concurrency now we are going to refer to as, everybody ready for the big reveal? It's already up here, but circumcenter. It's called the circumcenter. That is where all 3 perpendicular bisectors meet in a triangle. Called the circumcenter. All right, now all of these points of concurrencies are going to come accompanied by a fact about them, all right, that I'd like you to know. I have given you triangle ABC. What I did was and I should have put more markings on. Can you put the following markings on? Congruent, congruent. And then 1, 2, 3, 1, 2, 3 on each side of the What are these lines I drew in based on the markings? What are these lines here? The blue lines on mine. These are perpendicular bisectors making point O the what? Circumcenter. Point O is the circumcenter. All right. First of all, does everyone identify that these are all perpendicular bisectors just based on the markings? We're good there. Okay. That means if they're all three of them are drawn, point O is called the what again? Circumcenter. And here is the fact we should know about it here. You can read through it. Are all concurrent at a point equidistant from the vertices. Here's what that means. I'm not going to have you draw it in because there's lines flying everywhere here. But if that is the circumcenter, the following statement is true. Segment OA, if I drew it in, is the same length as segment O. Name another vertice. B, same length as segment OC. That circumcenter is the same distance away, all three vertices. All right, that is the fact I need you to know for the circumcenter. Everybody good there? Circumcenter. How's it formed? When all three what intersect? Perpendicular bisectors. And what's the fact? It's equidistant from the vertices. That's just one. We're going to end up doing 4 total as far as points of concurrency are. All right, let's try to find it on our own now. Take a look at the example I've given you. Let's try to find this on our own. All right, it says find the coordinates of the circumcenter. All right, now, here's where the brain starts rolling here. Circumcenter, I start thinking about the what? The intersection of the perpendicular bisectors. That's the only one you know right now. So what I need your help with is, where are the perpendicular bisectors on this triangle? So I can find that one point where they all intersect. Now I'm going to give you a little hint. You don't need to do as much work as we did on the first triangle. You don't need to find midpoint, do up and over, draw it in. What type of triangle am I working with here? Yeah, right triangle. Yep, right triangle. And specifically, don't tell me a straight. What type of line is this right here, AB? That's a vertical line. What's always perpendicular to a vertical line? A horizontal line. But if I'm looking for the perpendicular bisector, that horizontal line's got to go through the what of AB? Midpoint in your group right now. Find the midpoint of AB. You don't need to use the formula. You can count if you want. Put a little point where the midpoint is right now. Put a little point. No, you don't need to. No need here. So, hey, guys, how long was AB? 8 units long. So the midpoint will be how many units from A or B? 4. All right, perfect. So I'm going to go 1, 2, 3, 4. And what type of line is going to be perpendicular to AB? What type of line? I got the bisector. It's going to go through that point. What type of line will be perpendicular to vertical line AB? Horizontal. Draw it in. Take your straight edge. Draw in that horizontal line, making sure it goes through that midpoint. Everyone all right? We're guaranteed that that's the perpendicular bisector. It goes through the midpoint, and it's perpendicular to AB. What other side would this be pretty easy to do? BC. This is a horizontal line. Find the midpoint of it real quick. How long's BC? 8, so the midpoint will be 4 away from B or C. And what type of line would be perpendicular to this horizontal line, BC? Okay, draw it through. It's nice when it's a right triangle, right? Okay, now I got a question for you, honors kids. I got one more side. I got to find the perpendicular bisector for AC. Or do I need to? Why don't I need to? I know where it's going to intersect. As long as I'm confident in myself that I did these first two right, shouldn't it intersect right there? All right, so let's save ourselves some time. You don't need to do all three anymore. All right, if you're confident in your abilities, you only need to do two of the sides, because I already know where this third one's going to intersect, right here. I don't need to show it. I'm pretty confident in my ability that it'll intersect right here. So there is the circumcenter. I just need to find the coordinates of it now, because that's what the problem was. Find the coordinates. Circumcenter is hey, and here you're falling into the mistake everybody makes. You start from the origin, counting from the origin. You don't start counting from point B over. All right, start from the origin, please. So what's that point of the circumcenter? Over 5 up 5. Okay? Questions there from you guys? Anything? All right, another application of this now. Yep, we have a sink, a stove, a refrigerator, and a sink. Yeah, stove, sink, refrigerator in the kitchen. I need to place an island that's the same distance from all 3 points. I need a point that's the same distance from K as it is from S as it is from R. Now, if we see here, K, S, and R could be vertices of a triangle. And you only have 1 point, but what's the point called equidistant from K, S, and R? Circumcenter. So I need your help locating the circumcenter for triangle KSR. All right, oh, start the brain rolling. The circumcenters were all what intersect? All 3 perpendicular bisectors. Okay, this isn't on a graph anymore. So midpoint slope is out the window. Is there any way I have shown you this year to use one of these devices to do a perpendicular bisector? Yes, let's do it. Oh boy, we need to review. Okay, so I'm going to do KR. So I take my compass, put it on one of the vertices, open it up, more than half the distance of the segment you're bisecting. And yes, this is the fish one here. And then I go over to the other end point of the segment. Ah, shoot. Let's try this again. Using a straight edge, draw in your perpendicular bisector. There's one. Now, suggestion now, do a second side now. Same thing. Yes, you're going to have construction marks going everywhere. All right, let's keep it going. So pick another segment to do the perpendicular bisector for. Open it up more than half the length. I'll go green here for this one. Maybe not. And we talked last problem. Do I need to go to the third side and do it again? No, but some of you guys that want to check just to make sure, maybe you want to try it out. That's your call. I'm only requiring 2 of the sides because I should know where it intersects. And hopefully, depending if our compass opens and closes a little bit as we do it, it should be right on or below or just above KR, somewhere in this vicinity though. All right, somewhere in the ballpark. That is where I should put the island. To guarantee it's the same distance. You're going to have to do this over the little break you have here too. Except I think you got to put a water fountain equidistant from the slide, the merry-go-round, and sandbox, something like that. Okay. We all good there, guys? All good. So one more quick review before we get to the next one, because we're going right up to the bell today, so please don't pack up on me early. What'd you learn about the perpendicular bisectors in any triangle? They're all, let's use our big words here. All three are concurrent at a point called the circumcenter. And what's the fact about the circumcenter? It is equidistant from what? The vertices of the triangle, yes. All right. All right, next one. Let's review how to construct the angle bisectors. Let's review how to construct the angle bisectors. So I need you to bisect angle A and angle B for me here. All right, let's go. A little review. Let's go. Keep focused. Put your compass point on whatever A or B, whatever you're going to bisect. Make an arc that intersects in how many spots? Two spots. Intersect two spots in the sides of the angle. And then from here, anybody remember? Yep, you have 2 points of intersection on purpose, so you can put your compass point on those 2 points. And just make sure these next two arcs that you make are the same opening of your compass. I hate when that happens. I got to make the first one longer. But hey, happens to the best of us. There you go. And can you do the same thing for angle B as well? Go ahead and do the same thing for angle B, bisect it. Hopefully our angle bisectors intersected in the same spot. How's ours looking? Right around the same spot in your triangles? Because I know we were going to run out of time, I'm not having you do the third one. But if we were to do the third one, if we were to bisect this angle over here, guess predictions. All three angle bisectors would be, let's use the word, all three angle bisectors would be concurrent. Yes, so there's the conclusion we're going to make. In a triangle, all three angle bisectors are concurrent. Just like the perpendicular bisectors, where the angle bisectors all meet at the same point. And we do have a name for that point. You had the circumcenter. Now you have what's called the incenter. That is where the angle bisectors meet. So again, quick review. Where do the perpendicular bisectors meet? Circumcenter. Whoa, whoa. What's the fact about the circumcenter? Equidistant from the vertices. Angle bisectors meet at the incenter. Fact about the incenter before we go here. They are not, stop, they're going to miss it, and homework's going to be bad here. The incenter is not equidistant from the vertices. Ready? It is equidistant from the sides of the triangle. All right, the sides of the triangle. So everybody here, I have my angle bisectors. Point D would be my what? Incenter. So that means, ready? DE is congruent to? No, DE would be congruent to? DG congruent to? DF. Yes, they're not equidistant from the vertices. They're equidistant from the sides. Homework is at the bottom of that page right there. Everything out of the textbook.